Exponents. So you had a whole table of properties there that will come in handy for doing these. You also had, or should have had, a little phrase that said negative exponents, put it where it ain't, make it positive. So if you have something that's negative, we're moving it to the point where it would be positive. Also, I don't know why this thing has been like relatively blurry today, so if at any point it's blurry and I don't recognize it, you can tell me and I'll focus it back in and hopefully it'll cooperate. Alright, first problem, say to evaluate the expression, tell which properties of exponents you used. I do not care about the property that you use, I just want you to solve it. Okay, so we've got in parentheses 4 raised to the negative 2, and then that's cubed. So with these, it doesn't really matter which order we do things in. Okay, if you wanted to get rid of the negative exponent first and then cube the whole thing, you can. But I usually will do the power to the power first. And so what does that rule tell me that I do to like get rid of the power to the power? Or like, not necessarily get rid of it, but multiply them. So this is going to become 4 to the negative 6. And then what do I do because of that negative exponent? It's on the top, so what do I need to do? It's the phrase. Put it where it ain't, make it positive. So it's on top, so that means I need it on the bottom. So this is going to be 1 over 4 raised to the 6th. Well done. Okay, thanks. We just started, so you haven't really missed anything. Now, I'm fine with you leaving it there. I'm going to tell you that a lot of cases, the book is going to go ahead and multiply that out at that point. Now, the temptation is, because you have a calculator, is going to be for you to just type that in and give me an answer. You need to show me the steps that you use to get there. Okay? Now, if you went straight from here to this, that's fine as well, but I need to see that you actually have it written out, that you're not just typing it in your calculator and getting the decimal answer, which this decimal would be 0.00024 if you were to multiply that out, but I would take it either of these options, as long as you show me the steps that you use to get there. Now, if it's something that you know, like I don't think you know what 4 to the 6th is off the top of your head. More than likely. Okay? Now, if it's something like 2 to the 4th, you know, you should be able to do that relatively easily. And be able to, if you're going to leave it. Let's see. 6. In parentheses, 2 to the 4th, all raised to the 2. So what do I do with this one? Multiply them. So this is going to be 2 to the 8. And what is that? Huh? Should be more than that. What did you say?
256.
Yeah, that sounds right. I think you missed a couple 2s in there.
Just a little.
Only 2. Alright, 8. Oh, and Tristan, since you weren't in here, I told them that the instructions say that you have to say which property of exponents you're using, but you don't have to do that part. 3/5 raised to the 4th. So when I have a fraction and the whole thing is being raised to a power, what do I do with that? Okay, power of a quotient, so what does that tell me that I need to do mathematically? Yeah. Yeah, that's the easiest way to say it. So the exponent's going on both pieces of the fraction, so this is going to be 3 to the 4th over 5 to the 4th. We should be able to do 3 to the 4th in our head. Yep. Now, 5 to the 4th, I'm not expecting that you necessarily know that. You might be able to figure it out relatively easily, but you probably could do 5 cubed, and then you would have to multiply by 5 again, but since you have your calculator, if you want to type it in, you can. But. Yep. So, and they're going to leave their answers in this fraction form most of the time. They're not often going to use they're not typically going to change them to a decimal. Like this one I did up here as a decimal, they probably left that, but if you were to type it in, I would be fine if you gave me that one. So, let's see. 10. 9 cubed times 9 to the negative 1. So when we're multiplying two things that have the same base with exponents, what do? Yep, add the exponents. Now obviously one of them is negative in this case, but I'm still adding it. So this would be 9 to the 3. I'm just going to do the minus 1. It would typically be plus negative 1, but which is going to end up being 9 squared or 81. Now, if you didn't write this step here, the first one that I wrote, that's fine, but I would want to see the 9 squared before you go all the way to 81, just so I can see that you know what you're doing with the exponents. Let's 12. We've got 2/3 raised to the negative 5 times 2/3 raised to the 4th. What do I do with this one? Yep, so since they have the same base, I'll do the same process here. So this is going to be 2/3 raised to the negative 5 plus 4, which is 2/3 to the negative 1. Now what do I do because of that negative 1? Okay, so yes, I would put it over 1, but since it's a fraction, when it's already a fraction like that and it's being raised to a negative exponent, I can just flip the fraction over. Because ultimately that's what I'm going to end up doing, because I can't leave it as 1 over 2/3. I'm going to have to keep change flip. So a fraction that has a negative exponent on it, we can just flip it. So this is just going to become 3 over 2. Last one of this type. 14. All right, I've got a double parentheses here. So I've got a parentheses, then I've got another one with a 1/2 inside. The 1/2 is raised to the negative 5. Close the parentheses, all raised to the 2. Now, that's how they wrote it. Anyways. So what would my first step be with this one? And there's 2 different ways you could go about starting this one, so either one is fine, but. Okay, you can. That's. So it's negative, so what do I need to do?
Switch it, so we should put 2.
Yep, so no. So it's 1/2, okay, raised to the negative 5. So that negative tells me that I need to do what? Flip it, okay? So since it's a fraction, I'm going to flip it. So this is going to become 2 to the 5th squared, which is then what? So that's going to be 2 to the 10th. And somebody want to type that in and see what that is? Yes.
Technically, if you're on that second step, you can do 2 raised to the 5th. Well, couldn't you do it 2 raised to the 5th times 2 raised to the 5th? It's technically like the same thing. And then you can do what you did last week.
So that might work on this one, but it won't work on all of them. So that's why I wouldn't get in the habit of doing that. Now, the way that, personally, like I said, there's 2 ways we could have started this problem. So this was the one way. The other way that I typically do is I would have done 1/2 raised to the negative 10 first. And then I would have gone 2 to the 10 that way. But same amount of steps, doesn't change anything. But that's the other way you could have started that problem, and you're going to get the same result either way. So. Our next problems are scientific notation problems. Okay, so they give you 2 numbers in scientific notation, either being multiplied or divided. And we need to simplify it down. So, for some reason, I'm going to tell you people tend to struggle with these problems. They're pretty easy, but nonetheless, they still end up tend to causing problems. So, scientific notation. So, we've got 16, it's 1.2 times 10 to the negative 3 times 6.7 times 10 to the negative 7. So the reason this is in this section is because they want us to do something about these here, okay? So we've got the same base, okay, everything's being multiplied, so there's the same base. That means that I can do what with the exponents on those, the powers of 10? I can add them. So disregard the other part for a second, so leave a little space in the front. So I'm going to have 10 to the negative 3 plus negative 7, okay, for that part. Then over here, I'm going to multiply the numbers that are in front. So it's going to be 1.2 times 6.7. And I'm going to have to pretty much, I mean, you can do that by hand, but I would just say use your calculator to type that in. So when you type in that, somebody tell me what the number that gives me there, just this first part. Now over here, when I add these exponents together, I'm going to have 10 to the negative 10. Now, rules of scientific notation, okay, because I don't know, you're all in biology, right? You probably don't have a ton of scientific notation this year, but I'm guessing you did last year at some point. So, how many digits are allowed to be in front of the decimal point in scientific notation if it's done correctly? One. Okay, so this one is fine. But sometimes when you multiply those numbers, there ends up being 2 or even 3, depending on what the numbers were. And so we would have to move it over and then readjust our scientific notation. So this one's fine. Okay, this one is in correct scientific notation. So that would be my final answer for this one. Let's see, 18. I've got 7.2 times 10 to the 9 times 9.4 times 10 to the 8th. So I'm going to do 7.2 times 9.4 times, I've got powers of 10, so 10 to the 9 plus 8. And once, again, you don't have to show this part. You can just go straight to what that number is. But what's 7.2 times 9.4? $67.68 times 10 to the 17th. So this is one where I have an issue here, okay, because there's 2 digits in front of the decimal point. So I'm going to move it over to the left 1 spot so that I get 6.768 times 10 to the, but what happens now that I've moved this decimal point over here? No. Yep, I need to add 1 over here. So this is going to now be to the 18th. Now, I know where you're coming from with the too many on the right side, but we don't care about that in math class. We only care about that in science class when we care about significant figures. So this would be putting it in correct scientific notation here, like this. Now, the process is the same when I do dividing, okay, other than, you know, I don't add the exponents in this case. So 22, I've got 1.1 times 10 to the negative 3 over 5.5 times 10 to the negative 8. Now, in scientific notation, are negative exponents okay? Yes, okay. That just tells us that the number is getting really, really small, right? But I can't have 2 of them. I'm trying to simplify this down, okay? So I need all of my exponents to be on top, okay? Even if that results in a negative or whatever, it still needs to be moved to the top. So how do I move this one up here? Nope. It's that special phrase that I gave you at the end of the notes. Put it where it ain't, make it positive. Now, if that number was already positive, okay, the other phrase that I will sometimes say is put it where it ain't and change the sign. Okay, so if it was positive on the bottom, I would have to make it negative to move it to the top. You're just doing the opposite thing. But typically we don't like negative exponents, and that's why we say put it where it ain't, make it positive. So I'm going to be adding this one up to the top. Okay, so I'm still going to be doing 1.1 divided by 5.5, so somebody can type that in, times 10 to the negative 3 plus 8, okay, because that's how I move that up. So 0.2 times 10 to the 5th. Now, is this incorrect scientific notation? Okay, what do I need to do to make it? Okay, I need to move the decimal over this way this time. So what does that do to the exponent on the 10? Subtract 1, so this is going to be 2 times 10 to the 4th. Huh? Got the hard stuff out of the way, now we can go back to the easy stuff. A little more comforting for 4th quarter, right? Okay, so far everything we've done has just been with numbers, but sometimes they give us variables instead to do exponents with. Variables are going to work the same way. If it's not the same variable, you can't combine the stuff. So like you can't combine x and y still, just like with like terms when we're doing things with exponents. So do a couple of these. 24 w to the negative 2 over w to the 6. So we're back to I can't have negative exponents. The only time you can have negative exponents in the final answer is in scientific notation. Okay, everything else I need to make them positive. So what do I need to do with this one?
Do you subtract the exponents?
What do you mean?
Quotient of powers.
So I have a negative exponent on the top, but a positive one on the bottom. So the issue is what? The fact that this is what?
Wait,
Negative. So I need to
wait, where it ain't. Make it positive.
put it where it ain't, make it positive. So I'm going to move it to the bottom. So this is going to be 1 over w to the 6 plus 2. And again, you don't have to write that step out, but I'm doing it just so you see what's happening right now. So this is going to be 1 over w to the 8th. And that would be your answer.
How'd you come to exponent from the bottom? You're just gonna have it.
You can't have a negative.
Okay.
Now, if they're both negative, then I'm going to move the one that is the most negative. Okay, so like if instead this was, let's say if I modified this, and this was w to the negative 2 over w to the negative 6. Which one of those is the most negative? Negative 6. So I'm going to move that one up to the top. So this would become w to the negative 2 plus 6, which would be w to the 4th. So in the end, okay, I have to have everything be positive, all my exponents. Now, some people would tend to do this problem and flip these and give me instead, they would be like, well, this would be w to the 6 over w squared. But then you still have to move this up to reduce it because you have to have it as simple as possible. So you might as well just do it this way if you're going to do it. 26. In parentheses, p cubed, q squared, all raised to the negative 1. Now again, 2 ways to do this, but one is a much easier way to do it than the other. What do you see as the problem at this point? There's a negative, so I'm going to put it where it ain't, make it positive. So that's just going to make this whole thing be 1 over p cubed, q squared, and nice and simple and easy, I'm done. Okay, some people instead like to do this, which is fine, but it just adds another step. They'll make this p to the negative 3, q to the negative 2, then they have to do the step of moving it down to the bottom by changing the sign. Okay, so either way is fine, but if you can do it in less steps, it's a great option, right? 30. X to the negative 1, y squared over x squared, y to the negative 1. So now I've got two things happening, top and bottom. So what issues do we see? There's negative and it's on different variables. So I'm going to put it where it ain't, make it positive. So this is going to become on top, I'm adding the y. So it's going to be y cubed over, on the bottom I'm adding the x. So that's going to be x cubed. So y cubed over x cubed. Two more and we'll be done. 32. 4r to the 4th, s to the 5th, over 24r to the 4th, s to the negative 5th. So this one now adds numbers back in, but they don't have any exponents on them. So if there's ever numbers top and bottom, I'm just going to do normal, like, reducing rules of fractions. So what is that 4 and that 24 going to reduce to?
4 to 1, 24 to 6.
Yep, so that's going to become 1 over 6. Now, I'm I'm gonna just extend this, and if I need to write other stuff. So, how about the r's? They're both r to the 4th, so what's happening? Okay, they just cancel, and the technical reason is because you'd have r to the 4 minus 4, which would give you r to the 0, and anything raised to the power of 0 is 1, okay? So no matter what number I give you, if I tell you it's raised to the power of 0, you tell me it is 1, okay? So the r's are gone completely because of that, / they're also just the same thing, so y'all know the normal canceling rules. Now I've got s to the 5th and s to the negative 5th. So what do I need to do?
Make it positive.
Put the one that's negative where it ain't, make it positive, so I'm moving this one up. So it's s to the 5 plus 5 or s to the 10th. So this would end up being s to the 10 over 6, which if you leave it this way, that, that's fine. But that would be the final on that one. All right, this next one I want you to try on your own, okay, because I tend to give you one like this, at least on a quiz or a test at some point, that we've got y to the 11th over 4z cubed times 8z to the 7th over y to the 7th. So take a minute and do that one. And remember, even though there's no negative exponents here, I still can only have each variable and stuff written one time. You have an answer?
I have an answer, but it's sure it's right.
Just say it anyways.
Y to the 4th z to the 5th.
Okay, is that what everyone has? What do you have?
I'm wrong.
I got y to the 18 plus 2z to the 10.
Unpulse.
Anyone else have a different answer?
I got y to the 4th, 2z to the 4th over y over 7.
Not the y was.
Okay, anyone else?
I got
Ella.
y third plus y cubed plus 12z10. I don't know.
I got y to the 18 over 32z to the 10.
I don't know.
Okay, Maya's right, except for you need to change the order of it. Numbers should always be the very first thing that's written, okay? So, the 4 and the 8, okay, that reduces like normal, so that becomes a 2, okay? Then the y's, okay, I know why you're getting the 18 and the 10s, okay, I see where you're getting that from. You're moving it and you're thinking, oh, I need to add them. But if it's positive, when I move it from top to bottom, I've got to make it negative to move it. Okay, so it's actually subtracting. So the way that rule should really be written, but again, like I said, normally we do it that way because we can't have negative exponents. But it's really put it where it ain't and change the sign. So when we're moving something over the fraction bar, okay, even if there's not one to begin with, but if we're moving it over the fraction bar, then we have to change the sign of it. So since those ones on the bottom were positive, I had to subtract them off on the top to get that. So 2y to the fourth d to the fourth.
Okay, so like I
thought that was y to the fourth.
kind of did it
Yeah.
right. I just wrote it differently when I solved it. I
Oh.
canceled instead of like writing the second one, which color I put it in order.
But when you do these problems, okay, couple things about them. You always want the number written first, okay? So like obviously up here in this problem, it was technically 1/6 s to the 10th, but I just wrote s to the 10 over 6. That's fine, okay? But in this one, I want the 2 out front. I want any numbers that I have out front simplified as much as possible. Then I want my variables written in alphabetical order. Now, is it wrong if you don't do that? No. But that is the technical correct way to write them. And when you get to AP and stuff like that, not that these are going to be questions this easy on there, but when you get there, they're going to write stuff in alphabetical order. So it's better just to get in the habit of doing it now. But any exponent questions? Yes.
How'd you subtract this at for these?
So this was a positive 3 on the bottom, so to move it, I have to change the sign of it. So.
So I got it right.
All right, so problems for this section. 3, 7, 11, 19. Now, 19 is a scientific notation problem that's a little different than the other ones that we had, because it's a piece of it's a number written in scientific notation raised to a power, so that power's got to go on both pieces of that, just so you know. 23 combines the multiplying and the dividing of scientific notation, so that one's going to be a little harder, so if you have questions about it, just ask, after everyone's done it. We can go over it tomorrow or something if there's an issue. And then 25, 31, and 35 of the variable ones.